Okay, rates and ratios. So a rate is a type of ratio that's used to compare two measurements of different kinds. They're often used to describe and compare how quantities change. So an example of a rate is speed, which is represented in kilometres per hour. Graphs compare one quantity with another, and the gradient or slope is a measure of how fast one quantity is changing with respect to the other. The diagram in this image shows the relationship between distance, speed, and time. So to calculate speed, you do distance divided by time. To calculate time, you do distance divided by speed. And to calculate distance, you do speed times time. Equivalent ratios. A ratio is equivalent to another if they can be converted into the other by multiplying or dividing by a factor. Ratios are generally written in simplest form, and to simplify ratios, we divide all the numbers in the ratio by the highest common factor. Ratios compare quantities in the same unit. Ratios contain integer values without units, and they can be converted into fractions. To divide an amount into a given ratio, we can determine the value of the whole, create fractions that represent each part of the ratio as a fraction of the whole, and then multiply the value being divided into the ratio by each fraction. To compare ratios, we write them as fractions with a common denominator. Our success criteria for this unit is that I can solve ratio problems involving fractions and percentages, and that I can solve rate problems involving fractions and percentages. Our life link is through pay. So when working a casual job, you're paid an hourly rate. So you use that rate to determine your total pay for the week, day, month. Unit prices, so supermarkets have to display the cost per 100 ml, 100 gram. And then also to calculate distance, speed, or time is another example of using rates. So our worked examples here, our first one is to simplify the ratio. So we need to have a look and see if we can find a highest common factor. So for 21 and 14, our common factor will be 7. So I want to divide each of them by 7. So 21 divided by 7 will give me 3, 14 divided by 7 will give me 2. And that is in simplest form. Now, you may not be able to see that divisor straight away. So, like, for example, here, if I've got 88 and 132, I know both of them are even. So I might divide by 2 first. So then I'm going to have 44 and 66. Now, I can see that there's still a relationship between these two, so I can divide by 2 again. So 44 divided by 2 is 22, 66 divided by 2 is 33. I now have a look at these two numbers and know there's nothing in common, so it's 22 is to 33. Now you could have done that straight away by dividing by 4, or you can do multiple steps, it's up to you. Okay, 50 and 15, so we've got a common factor of 5. So I'm going to divide both sides by 5, so that means I'm going to have 10 is to 3. Now here I've got 8 centimetres to 12 centimetres, so first of all let's write that as a ratio, so 8 is to 12. I'm going to divide by 4. So 8 divided by 4 is 2, 12 divided by 4 is 3, so we've got a ratio of 2 is to 3. And then we've got 75 cents to $3, so I'm going to write that so that they're both in cents, so 75 is to 300. I'm then going to divide by 25. So 75 divided by 25 is 3. 300 divided by 25 is 12. And then there's a common factor between them of 3, so I'm going to divide both sides by 3. So we have a solution of 1 is to 4. Okay, I want to complete the ratio pattern. So I've got 2 is to 3, 4 is to 6. So you can see here 2 times 2 is 4, 3 times 2 is 6. Now 2 times 3 is 6, so 3 times 3 is 9. I then have 6 times 2 is 12, so 4 times 2 is 8. 12 times 2 is 24, 8 times 2 is 16. Okay, example number 3. James likes strong cordial and mixes ratio in the format of 2 parts of water to 5 parts concentrate. So I'm just going to write the ratio down straight away. So he mixes 2 is to 5. Matt also mixes cordial, but his ratio is 3 parts of water to 6 parts concentrate. We want to know who made the stronger cordial. Now, to work out strong cordial, we want to know which one has the greater amount of concentrate in the whole parts. So here, James, his total parts of the drink is 7. And so the amount of concentrate for the whole is 5/7. So James's cordial is 5/7. That's how much concentrate is to the whole. And Matt has got 6/9 because 6 plus 3 is 9. So 6 parts of his 9 whole is concentrate. Now we need to compare these fractions, so we need a common denominator. So 7 and 9, we will multiply James's denominator and numerator by 9. So you're going to have 5 times 9 over 7 times 9. And Matt's, we're going to multiply both the numerator and denominator by 7. So 5 9s are 45. 7 9s are 63. 6 7s are 42. 9 7s are 63. So you can see here that 45 over 63 is going to be greater than 42 over 63. So what that means is, therefore, 5/7 is greater than 6/9. So James made the stronger cordial. Okay, example number 4. So a physio sees 160 patients in a week. Determine the number of patients seen per hour if he works a 40-hour week. So patients per hour is the number of patients over hours worked. So he saw 160 and he worked 40 hours. So that means that he sees 4 patients per hour. Determine the time spent with each patient on average. So time equals in an hour and the number of patients. So in 1 hour he sees 4 patients. So a quarter of an hour is 15 minutes per patient. If he wants to make $10,000 per week, what's the minimum he must charge? So cost per hour is wage over hours worked. So he wants to earn $10,000 in 40 hours. So 10,000 divided by 40 is 250. So he needs to earn $250 per hour. If he sees 4 patients per hour, cost per patient is going to be 250 divided by 4, which is $62.50. Okay, example number 5, we want to simplify the ratios. So I'm going to convert it so that they're in the same measurements. So we've got 300 mil, and then 4 litres to mil is 4,000 mil. Now, first thing I can do is I can see that both of these are going to be divisible by 100. So I can divide both by 100, which will cancel out those zeros. So I then have 3 is to 40, which is as low as it can go. The next one I've got 500 is to, and if I convert this, it's going to be 2,500. Sorry, I shouldn't have the grams in there. You then are going to divide, so I know 500 goes into both of them. So you're going to have 1 is to 5. 1.5 minutes to 300 seconds, so I'm going to convert this to seconds. So I need to do 1.5 times 60 is to 300. Now 1.5 times 60 is 90. So you got 90 is to 300. I can divide both of those by 30. And I end up with 3 is to 10. Now last one, I'll convert kilometres to metres, so 2,000 metres, so it's 2,500 is to 2,000. So I know that 500 goes into both of them, so let's divide by 500 first. So that's 5 is to 4, and that is in simplest form. Okay, I want to complete the ratio pattern. So you can see here 48 to go to 24, I divide by 2. So then 64 I also need to divide by 2. So this side would be 32. To go from 24 to 12, I need to divide by 2. So 32 down, divide by 2, which is 16. 16 to 8, I divide by 2. So 12 divided by 2 is 6. And then to get my last one, I can also divide by 2 again. So then I'll have 3:4. Okay, example number 7. So Rose and Michael buy a lotto ticket that costs $10. How should the winnings be shared if their respective contributions were $2.50 and $7.50? So the ratio is $2.50 is to $7.50, and I'm wanting to share $50,000 in that ratio. So I want to know, well, if this is 10 parts in total, how much does each part get? So total parts is 2.5 plus 7.5, which is 10. So one part is 50,000 divided by 10, which is 5,000. So then Rose is going to get 2.5 times 5,000, which is 12,500. And Michael is going to get 7.5 times 5,000, which is 37,500. Sorry, I'll just fix that number up. So 37,500. You can see if you add both of those numbers together, that gets you up to your 50,000. Okay, compare the cars. We want to know which is more economical. So the first car used 41 litres of petrol to travel 500 kilometres. The second one used 34 litres of petrol to travel 400 kilometres. So what I want to do is I want to work out, okay, well, what's the cost per 100 kilometres? So to get to 100 kilometres, our first ratio we need to divide by 5. Our second one we need to divide by 4. So in 100 kilometres, the first car used 8.2 litres. And the second car in 100 kilometres used 8.5 litres. So therefore, car A is more economical because it used 8.2 litres in 100 kilometres compared to B, which used 8.5 litres. Okay, and our last example here, we've got a table of values and we want to complete this. So it says that a tank initially contains 500 litres. That means on day 0, it's got 500 litres. It's got a small hole in that tank and it's leaking 125 litres per day. So each day it goes down by 125. So if I want to fill in this table, it's 500 minus 125 minus 125 minus 125 to get to our solution. Now we want to construct a graph, so we need to use our ruler. And we need to construct our x-axis and our y-axis. Okay, so you need to make sure that your x and y-axis are scaled, so you need to use a ruler, making sure that you include all the values in your table of values and you have an even axis. I've just drawn that off the clock just because time is running out in the video. We then want to know when is the volume going to be at 100 litres. So what we do for this is we get our ruler, and if you've scaled your axes right, we go from the 100 on the y-axis and you plot across until you hit that line, and then you go down until you hit the axis. So you can see it's going to be just after 3 days. So you might say it's approximately 3.2 days. Okay, and when will the volume of the tank, what will it be after 2.5 days? So again, we go from 2.5 up to the line and across to the axis. Okay, and you can see that going up from 2.5 to the line and across the axes, we're probably sitting there at about 187 litres. Now we can use an equation to work this out. So in this case here, our equation would have been 500 minus 125n equals your volume.